Topic 4.3 Motion in a magnetic field. The motion of a charged particle in a uniform magnetic field. Here, when a charged particle having charge q and velocity v enters a magnetic field B, it experiences a force. Is nothing but Lorentz force. The Lorentz force formula F is equal to Q into V vector cross B vector. It is a vector form, or in scalar form we can write F is equal to QVB sin theta. Here following the three cases are possible. First case, when the initial velocity is parallel to the magnetic field, that means the theta is equal to 0. Substitute here sin 0, it will become 0, so total force will become 0. That means there is no force when a velocity in parallel to the magnetic field. Case 2, when the initial velocity is perpendicular to the magnetic field, here theta is equal to 0. Perpendicular means theta is equal to 90 degree. So F is equal to QVB sin 90 degree. Sin 90 degree is nothing but 1. So it will become F is equal to QVB. It's a maximum force. Third case, it's a helical motion. Now we'll move to case 2. The motion of a charged particle moving in a magnetic field. See, a magnetic field B is directed normally into the plane of paper, as shown in small crosses. It's given small crosses, they indicate magnetic field. A charge plus Q is projected with a speed V in the plane of the paper. The velocity is perpendicular to the magnetic field. When a charge particle perpendicular to the magnetic field, it moving in a circular path. So a force F is equal to QVB act on the particle perpendicular to the both V and B. Suppose when a velocity of the particle perpendicular to the magnetic field means the velocity of the particle moving in circular path, it's nothing but magnetic force or Lorentz force is F is equal to QVB. Now, thus the magnetic force provides the centripetal force. When an object is moving in circular path means it's produce centripetal force. Here the R be the radius of the circular path. So here centripetal force and magnetic force are equal. So centripetal force is equal to magnetic force. You know the formula for centripetal force, mv square by r. So is equal to magnetic force QVB. Here VV cancel, so we can write mv square by r is equal to QVB. VV cancel, so mv by r is equal to QB. So want to find r, so mv by QB cross multiply, so you will get r is equal to mv by QB. Now want to find the period of revolution. T is equal to circumference of speed. Already you know the formula for speed. V is equal to displacement by time taken. So you want to find the time taken means time period or time taken. T is equal to S by V. So particle moving in circular path, so it's nothing but circumference displacement and divided by velocity V. Now so T is equal to circumference of the circle is nothing but 2 pi r divided by speed of the particle is V. So 2 pi by V. Here R, you substitute the value R value here. So mv by QB. R value mv by QB. So here VV cancel. So it will become time period of the revolution T is equal to 2 pi m divided by QB. M is the mass of the particle. Q is the charge of the particle. B is the magnetic field. 2 pi is the constant. Now want to find the frequency of the revolution nu. So the frequency is inversely proportional to time period. So you can easily calculate the frequency. So reciprocal of the time period is nothing but what? QB divided by 2 pi m. It's the frequency of the revolution. You can easily calculate radius of the particle, radius of the circular path, and also you can calculate what? Period of revolution and frequency of what is that, revolution, nu also you can easily calculate. Next, case 3, helical motion. The helical motion, you see, a uniform magnetic field B is set up along the positive x-axis. A particle of charge Q and mass m enters the field B with the velocity v. Here you see 3 coordinate, x-axis, y-axis and z-axis. The direction of x-axis, the produced magnetic field B vector. Here one positive charge is present. When a positive charge moving inside the magnetic field, it produces Lorentz force. Lorentz force is nothing but circular motion. So here the mass m enters the field B with the velocity v. The incline, the angle theta. Here one angle created theta with the direction of the field B. In this place, the velocity v can be resolved into 2 rectangular components. One is the x component, another one is a y component. The x component is nothing but parallel. It's like this. You have to write v parallel is equal to v cos theta. And another one, second component, the v perpendicular is equal to v sin theta. It's a v perpendicular y direction and the x direction v parallel v cos theta. Now this centripetal force and is equal to magnetic force. It means when a charged particle moving inside the magnetic field, it produces Lorentz force. Lorentz force is nothing but circular path. In a circular path, the particle provides centripetal force and also produce magnetic force. The both forces always equal. The centripetal force is equal to magnetic force. So centripetal force, you know that one mv square by r is equal to magnetic force or Lorentz force is nothing but qvb. Here vv cancel. Again r value is equal to mv by qb. Here we know the formula for v is equal to r omega. V is the linear velocity, omega is the angular frequency, r is the radius of the circle. So v is equal to r omega. So omega is equal to, you can easily calculate, omega is equal to v is equal to r omega. Omega is equal to v by r. V by r. Already you know the formula. Omega is equal to v value, v into r value. Already you know the r value, mv by qb. Substitute here. So mv by qb, the qb will come to numerator. So q into b. So omega is equal to v into qb divided by mv. Vv cancel. So angular frequency is equal to qb divided by m. So angular frequency qb divided by m. Now want to find the time period. Already you know the formula for time period. T is equal to 2 pi by omega. So here is nothing but what 2 pi divided by omega. T is a time period. So T is equal to 2 pi by omega value. Already you know that one, qb by m. So you can write qb by m. The m will come to numerator. So it will become time period of the particle 2 pi m by qb. So time period of the particle t is equal to 2 pi by qb. Now want to find the pitch. The pitch is nothing but the linear distance travelled by the charged particle in the direction of the magnetic field during its period of revolution is called pitch. That means distance between the two circles is called what? Pitch. The pitch formula P is equal to V into T. In a parallel direction means you have to substitute V parallel T. Already you know the formula, pitch formula P is equal to V parallel time period T. So V parallel time period value, already you know that one, 2 pi m by qb. Substitute here 2 pi m by qb. So pitch is equal to 2 pi m v parallel, velocity in parallel q b. So it's called pitch. So pitch is equal to P is equal to 2 pi m v parallel divided by qb. This is a helical motion in a charged particle.